In this video, we're going to learn how to use inequalities to find possible side length of a triangle. It's quite a mouthful, but basically it's a lot of review from middle school information. So here's some quick review information. Mark the largest angle, longest side, and smallest angle and shortest side of a triangle. So we know that largest angle and longest side has to correspond with each other. So in this case, the longest side is here, therefore the largest angle has to be there. They're opposite of each other. And the shortest angle is here. Shortest side is there. Smallest angle is the opposite. Okay? And here's a theorem. It says, if one side of a triangle is longer than another, then the angle opposite of the longer side is larger than the angle opposite the shorter side. So to illustrate that, we have one side that's AB corresponding to angle C, and I have another side, BC, which is shorter than B, and that's corresponding to angle A. So because the blue is longer than the red, so the blue angle is greater than the red angle. That's how we draw the conclusion here. Okay? And the opposite of that, the converse of that is true as well. If one angle of a triangle is larger than another angle, then the side opposite of the larger angle is longer than the side opposite of the smaller angle. So again, here we go. We've got angle A at 50 degrees, and we've got angle C at 30 degrees. Obviously, angle A, the opposite of angle A, is line BC has to be longer than line or segment AB, which is AB is corresponding to the smaller angle C at 30 degrees. Here's a practical example. A long-tailed boat leaves a dock and travels 2,500 feet to a cave. So if I leave the dock here, I travel 2,500 feet to get to a cave. And then 5,000 feet to a beach. So the second stop is the beach. And then 6,000 feet back to the dock. So I traveled a triangle length. One of the angles in the path is about 55, and one is 24. So we know the third one, even though it's not given, it has to be the difference between 180 and the two given angles added together. Okay? So what is it asking us? It's asking, what is the angle measure of the path made at the cave? Now, I know all three angles. I have my first angle here, second angle here, and third angle right here, except that I just need to know which angle is which and how do I assign them. So we need a little bit of more information than that. So let's look back. The cave is opposite of the 6,000 feet. Is it the 6,000 feet? Yeah, the cave is here. Yep, that's the longest side, right? The 6,000 feet side. That's the longest side. So by theorem 510, the cave angle has to be the largest angle. And as we mentioned, the angle measures sum to 180 degrees. So the third angle is 180 minus 55 minus 24, or you do what I did up there, 180 minus parentheses 55 plus 24. I think if I did my math right, so it's 101 degrees, and therefore this angle right here that we're asked to solve is 101 degrees. So here is another useful inequality theorem. Basically, all it says is that in a triangle, you pick any two sides, you add their sides together, that sum has to be greater than the third side. So, in other words, in this example, AB plus BC has to be greater than AC. And AC plus BC has to be greater than AB. And if you choose AC plus AB, then it has to be greater. Actually, why don't we do that here? AC plus AB has to be greater than BC. So it doesn't matter which two you choose. The sum of two sides has to be greater than the third side. See how we can use this in this example. A triangle has one side length of 14, another of 10. Describe the possible length of the third. So it's a little ambiguous. Let's see how we can get started here. Let x represent the length of the third side. Okay. Draw a diagram to help visualize the small and large values of x. So if I do that, the small value of x is right here. Let me get this different color. It's right there. Okay. And of the three sides, notice that that's the smallest side. Okay. And then use the triangle inequality theorem to write and solve the inequalities. So we know x plus 10 has to be greater than 14, which means that x has to be greater than 4, right? Now, you can't do x plus 14 has to be greater than 10, but that's kind of obvious because x has to be positive. 14 is already greater than 10. So you can get to a conclusion, but that conclusion has not exhausted all the solutions there. So now let's look at the other scenario when x represents the longest side, which is on top here. And now this time if I put 14 here, and maybe 10 there. Does that look about right? So maybe I'll do my x on top. So now if I do, if I draw my diagram like that, I know the two sides added together has to be greater than x. In other words, I can also rewrite this statement by saying x has to be less than 24. So in this case, I find a range that the length of the third side must be greater than 4, 4, but less than 24. And 4 and 24 are not included. Or you can say it's between 4 and 24. Okay? So that's how we use it. Make sure you complete the checkpoints to help you deepen your understanding of this unit.